Good morning, guys. Welcome back to another section of clarity, building on blockchain, building on stacks blockchain with clarity. So today we are going to really dive deep into learning the basics of clarity, how clarity works. I'm going to take you from a very beginner's level. If you don't understand the installation part we did in the last video, don't worry about that, right? Because we're not going to start building with our VS Code. We'll be testing out some things on the REPL editor online. Then once we are done understanding the very basics of Clarity, we'll to um, migrate our coding to VS Code. So I want you to relax and calm down, right? This video is definitely for people with zero experience in programming. If you have a zero experience in programming, you are in the right place. I'm going to take you from someone who doesn't know about programming to knowing about programming. All you need to do for me is understand your mathematics to your fingertips. Your mathematics is very needed here. If you don't have a math skill, it's going to be tough for us a bit. So would catch up. All right. So first of all, there's a link I dropped in the video. You'll check it out. Let me go back to the course page so that you see how it looks like. It actually looks more like this. Yeah, it looks more like this. So you'll see three courses here. This first one is really for advanced people, right? The second one is what you need. It's going to take you from bottom to the top level, right? So you tap on this. So this is the course we'll be working with. I'll be teaching you based on this course, and I'll be explaining what wasn't explained in the course because so many things were left out, right? To just let you figure it out on your own. But my job here is to break it down for you. So here is supposed to tell you register, right? I have already registered, and all I have to do is click on continue and move on with my life. So you can do me a favor by, start reading all these guys here. I'm not going to do that. I'm not going to teach you all this about blockchain, cryptocurrencies, and all that. Like I said in my last video, I can't really explain that, right? There are people who knows how to explain blockchain on YouTube. You can watch their video. But here, I would teach you about blockchain by teaching you how to build on blockchain. Because with the knowledge of building, you would understand how blockchain really works. I don't want to just teach you by mouth. So let's move on. So where we would start with is clarity basics. Clarity basics is where we need to start with. All right. So you can click this. There on each section there is a quiz, and this quiz is what I'll be checking out for. If you are on my Discord community, I'll be checking out for this quiz because I would want you guys to take that quiz and send a screenshot to the community, to the Discord server. Right? I'll create a quiz channel and make sure to drop it there if you are on Discord community. And then you walk us through how you solve that problem, right? How you answer the question, because I'm going to take up my time to ask questions and verify that you didn't cheat, right? Yeah. So I'm going to follow everyone up if you're on the Discord community. With that said, let's get started. Clarity basics. So clarity definitely looks like Lips. Lips was developed by this guy, yeah, and Steve Rosell. I don't know who they are, right? So this is a Wikipedia of Lisp, the history of Lisp. So you can definitely check it out if you want to know more about Lisp. As you can see, the syntax looks somewhat not funny. Yeah, there's an example of the syntax. So at first look, it doesn't it doesn't look conventional like in it doesn't look like in a more conventional language, right? It just looks weird. Yeah. So okay, clarity feature looks like syntax. So it looks like lips and it definitely works like lips. Now, I'm not going to read up all this. You can do the reading. I would explain from my head the easiest and simplest way how to understand this code. I'll just focus my attention on the code. Anything that I find a bit difficult to explain, I can capture information from the text and then use it to explain the code. So I might want to close this out, yeah, and increase my font a bit. I think that should be better. So if you notice, our plus is here. Why is plus at the beginning? It's crazy. It's supposed to be 4 plus 5. But anyway, how clarity works is that the operators comes first, no matter how you say it. The operators comes first. There's no two ways about that. So it's definitely 4 plus 5, which is 9. If you press this play button, what you get here is 9. It's messed up. But anyway, with time you get a hang of it, and then you quickly notice it's actually quite simple to understand. It's just that if you're a newbie, when you're looking at this, it looks confusing, both in a mathematical term and in a normal human term. In a like what you are used to, this is not what you're used to. So we have what we did over there was for integers, right? I know you don't understand what integers floats. Don't worry, we'll get to that. This is just to get you to understand how clarity syntax looks like, right? So you can read up all this. Now we have concatenations, right? Concatenations is kind of like adding two things together, mostly a string. If it is not a string, you don't want to use that concat. Concat is to add two strings together. It's the same thing as plus, but plus for strings. So if you hit this play button, you get hello world. So let's see if we can add extra string here and see what happens. It's an error, right? So only two items are being concatenated. So don't say, oh, we can now concatenate strings. Let me concatenate more than one. It's crazy. It's going to mess up what you're doing. So don't do that. Now, you can notice that when we run this, there is a space here. How did that space come about? Is actually this space right here. So if we close it up and run this, we'll get that closed space. Also, if we come here and put a space, we get an open space. So it doesn't matter where you put it, but be careful that you don't put a space here and boom, it becomes too extra large. So strings are used to maybe send messages. Numbers are used to calculate your money. Exactly. We'll get a hang of building projects with clarity, but you need to understand the basics. Am I even recording? Okay, yeah, I'm recording. I want to be sure. So you need to really understand the basics before you dive into building a project. So you might be wondering, what do I need concats and all those integers for? You need to know it because when someone makes a payment, you want to send them a message, right? Or you are building a chat, a chatting decentralized app for the blockchain. You would definitely need a string to be able to store people's messages, right? Or you want to send money, you will need an integer to be sending money up and down, right? Is is definitely how it works. So okay, now this is a more complex calculation here, but it's definitely simple. This is exactly how it looks like in a normal mathematics. But notice quickly that operators are always at the forefront. Yeah. So what does this do? First of all, evaluate what is inside of the inner bracket, right? Which is 15 plus 10 will give you 25. 25 plus 4 will give you 29. So definitely we would be having 29 here. No, that's not okay. Sorry, times 4. 25 times 4 is 100. I was thinking this plus. Okay, okay. So when things become more complex, you don't want to keep them on a straight line. If you keep them on a straight line, you will get confused immediately because it becomes very hard to read. Imagine I come here and put another bracket and then yeah, do something like minus 5 2. That is 5 minus 2. It becomes hard real quick because you're looking at it at a straight line. Like it becomes hard to read. But when you separate it this way, it becomes easier for your eyes to read it. So you evaluate the inner brackets and then multiply them. That is 2 plus 3 is 5. 6 minus 1 is 5. 5 times 5 will give us 25. Exactly what we're having here. So this is how lips work. Lips is crazy. It's like the person who wrote lips was drunk that he wrote lips. Is a joke anyway. Yeah. Okay. So in lips we have in clarity we have what we call comments. Yeah. So comments, in case you are new to programming, comment is a way to um, say what is happening in your code without executing that. So when you run this code, this then is ignored. This is ignored, and this is ignored. Now, imagine I did not put this there, and I came here and said this was not is a comment. Less mother English. All right. So if I hit this play button, you see this error. The following line is not evaluated because it's not enclosed in a comment. Use of unresolved variable this. So it's trying to capture this um, as an operation, but it's not an operation, right? We're not declaring any variable here. We're not making a statement. So for us to be able to tell our compiler, hey, we're just trying to explain what is happening here, we put this comment, right? And then when we run our code, it's going to ignore that and just focus its attention on only this guy. 1 plus 2, which is 3. Insane, guys. Insane. Insane. Totally insane. So, congratulations. You just completed your first session in ClarityNet. Um, understanding the basics of clarity. So, still on this video, we are going to head over to introduction to and clarity. So, and clarity is type safe. What do they mean by type safe? Is kind of like saying I have a plate. This plate is for food. You don't put a sand in it. You don't put water in that plate. This plate is only for putting food. You have, just like you have a toilet. You don't want to put uh, you don't want to pour your soup or your food inside the toilet. It's meant for your poop and your wee wee, your urine. Yeah, we call it wee wee here. Auntie, I want a wee wee. It's meant for your poop and your urine, right? You don't use it for something else. That is what type safe is in clarity. When you say a variable is, when you say this variable is storing a uint, an integer, which is a number, you don't use that variable to store a string, which is a bunch of text. It won't work. Clarity will tell you, hey, get out. You can't do that. You can't add a number to a string. On other programming languages, you can do that actually. Like Python, you can do a string multiplied by a number, though you can't do a string added to a number, which means saying hello plus an actual 2. Except you put that 2 in a string, then yeah, they will add. But if you do hello plus an actual 2, it's not going to work. So that is what is meant by type safety, right? So some programming languages enforces that, some don't. So we can see an example here. This is an integer. This is a U integer, unsigned integer. What is an integer? What is unsigned integer? What are the difference? The difference is this: integers have signs on them. They can be both plus and minus. Unsigned integer, on the other hand, are only positive, which means plus. So when we run this, you will definitely see it's not going to work. And now let's type int found uh, expecting expression of type int. So it's saying that, hey, I'm expecting 3 to be integer and not you int. So now let's do something. If I put you in front of 2, this is definitely going to work. But notice something I cannot do: 2 plus minus 3. Yeah, illegal variable. But notice quickly that I can do 2 plus minus 3. 2 plus minus 3 is what, guys? Is actually minus 1, which means minus 3 plus 2. Yeah, it's something as saying this. Let me put it out there so that some people will not get confused. It's same thing as saying this. It's still the same thing as saying this. 2 plus minus 3 is the same thing. So plus minus will give you minus. 2 minus 3 is minus 1. And when you run this, yeah, you get minus 1. Exactly. Notice that you can't put minus in front of u when there is a u. That is to tell you the difference between signed and unsigned integers. Signed integers are normal integers that has both minus and plus. Unsigned integers only has positive numbers. Unsigned, which means there is no sign in front of it. A positive number is already signed, like an integer. A unit is already signed one-sided. Like you don't see the plus, but there is a plus there. Yeah. So because it's positive. Exactly. So okay. So that's it. I will take this back to being this, and then when you plus this, you get this. All right. Now we have um, basic data type. Okay, the expression above results in an error, blah, blah, blah. Before we can properly answer the question of which type it was expecting, where, let us take a look at the different types in clarity. Types fall in 3 categories: primitive, sequence, and composite. So we are going to be looking at these types, and then we'll be understanding what these types or how they work. But first, this is what we would only do for this video, for this current video. After that, we'll write a quiz, and yeah, we'll write our first quiz. The rest of the other quiz in the future, you'll be doing them yourself. And do me a favor, bombard me with questions, and I'm with you all the way. All the way. All right. Okay, so let's head over to primitive types. What are primitive types? Okay, primitive types are basically your integers, booleans, principles. Uh, what are integers, booleans, principles? Yeah, I mean, you know what integers are already: signed and unsigned integers. You know what they are because we just explained it. What are booleans? What are principles? It's crazy. So let's get ahead. We understand both. Um, so we have, how many minutes is this video? Just checking out something. Oh, 21 minutes. Okay, fair enough. So we have signed integers. Sorry, where was I? Okay, we have signed integers here. Uh, int. Okay, like I've explained, you don't need to necessarily start reading this to understand 128-bit. Don't do that if you don't understand binary. If you don't understand binary system, don't bother reading this. You'd fail woefully. You'll fail woefully. I will teach you binary the best way I can, the simplest way I can. I'm not going to explain this to you guys. This one now, not never. It's in the future, right? Let's focus on the numbers that we understand. Let's not focus on the ones that will not even make use of it much often. So let's not bother. Also, let's not bother here. Yeah. So we have done this before. This will give us what? Can I hear? Can I hear? 5. U5, not actually 5. U5, but it's still 5, anyways. And then this will give us Can someone tell me the answer? It will give us 10 minus 5. Yeah. That is 5 minus 10. Yeah. So this is definitely 2 times 16, which will give us U32. So it's very easy. 100 divided by 4 is 25. Very easy. Like, it doesn't need an explanation. You just click and go, click and go. U10 divided by U3, yeah, 3.33333, whatever. So it doesn't give you that 3.3333 due to, I don't know why. Let's read why here. If you punch the above into a calculator, you will likely get 3.333. Not with integers. The above expression evaluates to U3. The decimals are dropped. That's it for integers. For booleans, booleans are true or false statements. A bool. So if you're a boy and I ask you, are you a girl? Your answer is definitely no. If you're a girl, I'll ask you, are you a boy? Your answer is definitely no, right? So booleans are a way to tell computers, are a way to help computers make decisions, right? Computers check some statement and see if it is true or false. If it is false, it's going to take some certain action. If it is true, it's going to take some certain action, depending on the instructions you gave it. So imagine true or false, imagine booleans as a superpower to the computer to be able to make decisions for you, to be able to make decisions whether to drain your wallet, for those building wallet drainers, to drain your wallet or not to drain your wallet. So these are the backbones of decision making systems in computer systems, depending on the action you take. So not true is what? Not true is going to actually invert this true. So when you say not true, is false. Because are you saying I'm not true? You're not a girl. When I'm a girl, if someone comes to your face and say you are not a girl, if you're a girl, someone comes to your face and say you're not a girl, say that's a false. I'm a girl. That's a false. If you're a transgender, someone says you and say you are she, they, them, they, she. That's true, bro. Exactly. So when you say not transgender, you're not a transgender, you're a man. No, that's true, bro. Yeah, I'm not a transgender. Okay, so and true and true and true. This is going to give us true. It's just saying true and true and true, right? If all these statements are true, yeah. So now here we have false, true, false, right? It's good. This is definitely going to evaluate to false, which means if anything is false, at least one. Okay, no, this is all, not and. If it is and, it's going to give us false. Sorry. So at least one of this is true. Exactly. If you run this, this is going to give us true. So let's check here. If one of these is false, the answer will evaluate to false because it is and. Okay. Now, principles. Principles are a way for us to represent contract IDs. You want to recognize a certain contract. You want to make use of a certain contract in your code to execute um, some task, right? Or you want to withdraw money from a user's wallet, right? Someone's wallet, right? You want someone to connect their wallet. How we represent them is via principles. Principles are a way to represent contracts, wallet IDs, wallet addresses, and contract IDs. A principal is a special type in Clarity and represents a Stacks address on the blockchain. It is unique. Stacks address, so it can be your money, whatever. It is a unique identifier you can roughly equate to an email address or a bank account. Exactly. So your money on Stacks, your wallet is that is your Stacks address. Your wallet address is a principal. And how can you access that principal to be able to transact with a user? It is using this principle, Stacks principle, right? It is a unique identifier you can roughly equate to an email address or bank account number. Although definitely not the same, you might have also heard the term wallet address as well. Clarity admits two different kinds of principles: standard principle and contract principles. Standard principles are backed by a corresponding private key, whilst contract principles point to a smart contract, just like I have explained. Standard principles are your wallet addresses. Principles are your contract um, um, addresses. Yeah, contract principal point. Your smart contracts. Exactly. Contract principles are your smart contracts. So if you want to identify a smart contract, you use a principle to do that. It's easy peasy simple, right? Principles follow specific structure and always start with the character SP for the stacks mainnet and ST for the stacks testnet and mocknet. So you don't want to use SP when you are testing. And then you plug in your wallet, and then you have like your $1,000 in there that you are testing something. Man, you forgot to change it. And then your $1,000 STX is gone. Everywhere just got silent. You want to use XT for testing and not SP. So be careful. A literal principal value is prefixed by a single quote. So this is an example of stacks principle. You want to declare it. If you notice in strings, we'll have double quotes, but here we have only single quote standing at the forefront. If you run this, you'll get the address. So this is for wallet addresses. The next one you will see is for um, contract, smart contract addresses. So this is how it looks like. It goes with dot, my awesome blah blah blah. There's always dot with it, always. So when you run this, exactly, you will get something like this. So with this, you can get the balance. Yeah, this is a code to get the balance of a wallet address. Here we have 0 naira. So I think you can plug in someone's wallet address here, and then get the actual price, the actual amount they have on their wallet. You will see that immediately. So yeah, both kinds of principal can hold token. So a smart contract too can also hold token. Yes. Um, I'm going to do this. Voila. Everything we have here is 000. The smart contract has 0. I mean, the wallet address has 0. The smart contract has 0. So with these guys, we have reached the end of whatever thing we are doing. You can read up this, but we have covered the basics of integer principles. If you have questions, I am on the Discord channel waiting for you to throw me questions. I'm waiting for you guys to throw me questions. All right. So you can test these codes out and see for yourself what's up, what's popping. Let's write this quiz and end this section. Okay, this video is 34 minutes. I'm going to prune some things out. So let me retake. Why should I even have 5/7? Whatever. Select the valid standard principle. So guys, which one is a valid standard principle? Principle. So is it this? Is it this or this? Which one? I think it's this. Yeah. Now, what would the following expression return? This is tough and true. So definitely this is returning false because one of it is false. Not false is true. Damn. So we're correct here. Select the valid contract principle. Damn. Is it this guy? Remember, it has a quote in front of it. Single. There's no ending quote at the end. It's definitely this guy. The last one here is for standard principle, not contract principle. Damn. Don't bite my mic. Okay. Is the following expression valid? So, we can definitely not have a negative number. We can definitely not have a negative number. So I think it's valid. I don't know. I might fail it. Yeah. What a nice play. Reverse psychology. It worked on this. So it's not valid because 1 minus 2 will give us minus 1. It's going to give us an error. It's definitely going to give us an error. So what will the following expression return? Is going to return an error because you can't add an integer to an unsigned integer. You can't add a signed integer to an unsigned integer. You don't want to do that. You don't want to do that. So the expression will return an error. Submit. Wow. Why did I get 5/7? Why? Maybe I was just checking it out and trying to brush myself up to teach you guys, right? Because after learning stacks, I wasn't learning stacks with this environment before. There was this old documentation they had. I was learning stacks there. So I got to understand stacks very well right now. So I'm teaching you guys. Yeah. The expression valid. The following expression valid. You want to say false here, please? Oh my gosh, submit. It's a false. Standard principles on mainnet starts with C, S, T. You guys tell me the final answer because I think it is false. But the answer is true, which makes it a false. Because if you say you are not this, it is true then, which still makes it a false. And then submit. Yeah. All right, guys. See you on my next video, and please practice this test. Run the repellate. There are 2 links I will drop on the link in the description. See this here. This is a coding environment. It's like executing your whatever instantly. So hello world, how are you? Is executing it immediately. It's going to appear here exactly. So instant you are seeing what you're doing, the result of what you're doing immediately. So we can check this thing out later when we start building some complex projects. We'll be making use of this to structure our complex project and run it and see it in real time. Clarity tools, guys. Yeah. All right, so I'm going to finish up this and now having 7/7. See you guys on my next video. Trala, trala, bame, trala, bamela.